Hey guys, welcome to another episode of Black Guy Does Physics, where we try and take the magic out of physics. Before we start today, I'm going to give a shout out to my AP Physics Mechanics class for doing a thing on that test. First of all, got to start with the leader himself, Mr. Hunor, for getting that 6. Chuckle. Then got to give a big shout out to my main man, Pat, for smashing it, getting that 5, man. Mr. Sebas himself, he said that he was going to do the thing, he did the thing. Congrats, bro. Now, for all of my people who got a 4, talking about Vicky, Tello, and Kiara. Kiara doing the thing. Thank you, appreciate it. For everybody else who actually did their thing, Gaspar, Gabriel, Big Brain, thank you, man. Came through clutch. Appreciate it. It was a great year, so hopefully we could do something else this year, but I appreciate it. It was a good year, man. I enjoyed it. All right, with all that being said, let's get it cracking. Now, today we're going to talk about sine, cosine, tan. Simple trigonometry. Before, in the previous video, we talked about Pythagorean theorem, which deals with the sides of a right triangle. With the sine, cosine, and tan, which is just basic trigonometry, we're dealing with the side and an angle. So the sine, cosine, and tan relates the sides to an angle. Okay? So before we get anywhere, we have to know the sides of the triangle itself. We should know the hypotenuse. The reason why we should know the hypotenuse is it is the longest side and it's the one that faces the right angle. So it's nice and easy to know. Okay? Most students don't have a problem with that one. The ones that I have a problem with is the adjacent and the opposite. This is the way that I do it. When I look here, this is where my angle is. So what I look for is the side that touches the angle that I'm using. And the side that's touching the angle that I'm using, it is my adjacent side. In this case, this side. And if that's my adjacent side, then the other side is my opposite side. Once we figure that out, you're good to go. Let me repeat that. The side that touches the angle that you're using is your adjacent side. That's the one you look for. Keep it nice and Gucci. And don't be a smart ass and say, oh, the hypotenuse is touching the angle too. We already know the hypotenuse, bro. Come on. So, sine is equals to opposite over hypotenuse. Cosine of an angle is equals to adjacent over hypotenuse. And tan of an angle is equals to opposite over adjacent. How the kids remember this is by saying SOHCAHTOA. They always laugh at me when I say it, but whatever makes you happy, man. So it's SOH, S-O-H. For sine is equals to opposite over hypotenuse. Ka for cosine is equals to adjacent over hypotenuse. To. For tan is equals to opposite over adjacent. SOHCAHTOA. If you could remember that, you're good. The way I learned it was sine is equals to old Harry. So that's sine is equals to opposite over hypotenuse. Cosine is equals to and his, that's cosine is equal to adjacent over hypotenuse, old aunt. That's the way I learned it. So sine is equals to old Harry, cosine is equals to and his, and tan is equals to old over aunt. It worked for me, man. If it works for you, that's fine. SOHCAHTOA works for you, that's fine. Whichever way. But you cannot go around not remembering this. You have to remember this. You have to. There's no way around it. There's none. Now, when it comes to physics class, and you're talking about sine, cosine, and tan, then usually it is associated with breaking down vectors, which I'll do in another video. But what you need to understand about vector, the funny thing about vectors is that they always come with a side and they always come with an angle. The side is that, the funny thing is the side itself is the hypotenuse of the right triangle. That's awesome. So you'll always have the hypotenuse of the right triangle. And you'll always have an angle of the right triangle. So you could always use sine, cosine, and tan. Now, because you're given the hypotenuse, that means that the two trigonometrical functions that you're going to use a lot, that is going to dominate when you're talking about breaking down vectors, is sine and cosine. So we could rewrite those two things by saying that the opposite side is equals to the hypotenuse, not cosine, my apologies, sine of the angle, and the adjacent side is equals to the hypotenuse cosine of the angle. In other words, if you're talking about vectors, the opposite side is equals to the length of the vector sine the angle, and the adjacent side is equals to the length of the vector cosine the angle. So in that premise, that's what we're using for vectors, for strictly physics. I'll talk about it in terms of mathematics if you're in your math class and you want to do this. I'll do a couple examples of that. Here, tan we're going to use only when we want to find an angle. Okay, but for physics class, these are the ones that dominate. So let's see what we could do. Let's put some numbers in there. Let's use black for this. So we're going to have 7. Let's put newtons. It doesn't matter what this stuff is. It really doesn't matter. You could put Kilimanjaro for all I care. It doesn't matter. Simple explanatory reasons. So let's put a 30 degrees here. Let's call this side X and this side Y. Why are we calling this side X and that side Y? Simple. For the X, it's the horizontal, and the Y, it's the vertical. That's what we do. So here we go. First of all, I want to check to see which side is touching the angle that I'm using. So I look and I could see X is touching the angle that I'm using. Sweet. So therefore, X is my adjacent, and I just look at my little formula up there. So that would give me 7 newtons cosine of theta. And then Y is just 7 newtons sine of theta. Why is it the sine? Because if X is the adjacent, then the Y has to be the opposite in this case. Nice and easy. It's so easy. Obviously, you'd have to, I put in theta. Let me erase that and put in cosine of 30, because theta is 30. We know it. Obviously, you'd have to put use your calculator to punch these numbers in, which you can do. Okay. Let's try again. Let's say 8 meters, and let's call this 20 degrees. Now this would be my X because it's horizontal. This would be my Y because it's vertical. So which one is my adjacent? I look at my angle and I could see that this is touching my angle. Therefore, Y is my adjacent. So Y is equal to 8 meters cosine of 20 degrees. And therefore, X is simply equals to 8 meters sine of 20 degrees. Man, easy. Cake. So it's so cake. Easy and tasty. All right, let's get it. One more. Let's put 1 here. Let's call this 15. Let's call this 20 meters per second. Once again, don't watch these units. It's whatever. This is my Y. This is my X. Y is vertical. X is horizontal. So which one is my adjacent? Huh, cool, dope. So therefore, you're going to see something here. They say Y is 20 meters per second cosine of 15 degrees. Therefore, X is simply 20 meters per second sine of 15 degrees. Don't let this ever get you confused. Let's see another one. So we go here. Let's use this. Yes, let's call this 60 degrees. And let's give this 10 meters, whatever. The units doesn't matter. This would be my X and this would be my Y. So once again, I look for which side is my adjacent. It would be X because it's touching the 60. So X would be equal to 10 meters cosine of 60 degrees. And Y simply would be equal to 10 meters sine of 60 degrees. Sweet. Now, the cool thing about this is that you could pick whatever angle you want to pick, man. So let's say you don't want to work with that 60 down there and you want to work with the angle at the top here. So this is 30 degrees, right? Because 60 and 30 gives you 90. So once again, I have to check to see which one is my adjacent. So in this particular case, this side is my adjacent Y. So if I'm using that top angle there, then Y would be equal to 10 meters cosine of 30 degrees. And then X would be equal to 10 meters sine of 30 degrees. Now, don't get confused and be like, oh my God, one is sine and one is cosine. No, bro, it's okay. The reason why is because the sine and the cosine of complementary angles are the same. That is, the sine of 60 and the cosine of 30 are the same. Same numbers. You could check it out on your calculator. It has to be. The sine of 70 and the cosine of 20 are the same. Or the sine of 20, cosine of 70. Same numbers. So these two things are equal to each other. Therefore, you're good. Let's get in one more. So don't get confused with that. Let's get in another one. Wow, this one is on its side, but once again, we don't worry. So let's call this MG. Let's get it real fancy. And let's call this, what haven't we used? We have used 20, whatever. Let's go with 20 degrees. Okay, so therefore this one, now you're going to be like, which one is my X and which one is my Y? We're going to call this X because it looks kind of horizontal, and this one Y. Later on in another video, I'll explain this out. So once again, you don't worry about what this stuff is. You just write it down. What is your hypotenuse? MG. So here we go. I check to see which one is my adjacent. This one is my adjacent. So now I see that Y is equal to MG cosine of 20 degrees. And my X is equals to MG sine of 20 degrees. See? Nice and easy, man. Don't, bother yourself too much. If you're worrying about what we do with tan, oh, I did say I would give you another example. Let's see if I could draw me another triangle here. Let's do a quick one for a triangle. This is if you have your regular math class. Oh, that didn't work out. If you have your regular math class and they're asking you for some for the angles or whatnot. So let's put the right triangle. Let's say you have 5 meters here and 2 meters. No. 5 meters here, and this is 10 degrees. And let's call this side H, and let's call this side Y. And you want to figure out, let's say you want to figure out which one, Y. Let's figure out Y. So once again, what do? I always find my adjacent side. So if this is my adjacent side, then I could say that this must be my opposite side. 5 must be my opposite side. Let me put that in a different color. 5 must be my opposite side. Right? So now I'm good to go. I could use my tan in this case because I don't have the hypotenuse. So I could say the tan of the angle, 10, is equals to the opposite side, which is 5 meters, over my adjacent side, which is Y. Therefore, my adjacent side should be equals to my opposite side divided by tan of the angle. And this goes either way for whether it's your opposite side or your adjacent side or whatnot. You just rearrange for it if you don't have the hypotenuse. And once you have the adjacent side, once you have those two sides, no, I should put 10 here, sorry. Let me put 10 there. Sorry. Once you have this, then you could use Pythagorean theorem to find H if you wanted. Or let's say you wanted to find H from the get-go. Well, if you wanted to find H, then H is there and 5 would be your opposite side. So you could see that your opposite side would be equals to H sine of the angle. So you just punch it in. What's your opposite side? 5 meters. Your hypotenuse H sine of 10 degrees. Therefore, H would be equals to 5 meters sine of 10 degrees. Which you have your numbers, you have a calculator for, so you could just punch your numbers in and solve. Ladies and gentlemen, that's it. There's nothing more to it. Just remember the little rule, write it down somewhere so every time you're doing this as practice, you could look at it. Man, hopefully you liked what you saw or like what you heard. Hit that button, smash that button, subscribe, bro, subscribe. And kids, please, don't be a moo-moo.